Hi, my name is Lucrèce Matron and I work in the biomolecular mass spectrometry and proteomics group, so the group of Albert Heck. And today I'm going to show you how to use titanium dioxide in order to enrich for phosphopeptide. The protocol is called a microcolumn enrichment protocol because your material will be packed in a very small column. So this is the equivalent of a pipette tip, where here the white particle is your titanium dioxide beads. So actually, the microcolumn looks like this, where most of the white part is titanium dioxide, and here at the end of the tip you have a C8 plug that is here in order to block the end of the column and prevent the particle from leaving the column during the enrichment procedure. So most of the protocol will be performed by centrifugation in a classical centrifuge in which you can accurately control the speed. And in order to do that, your microcolumn will be adapted into an Eppendorf tube with a system like this, where you have here an adapter that fits into the Eppendorf tube and into which the microcolumn can fit. And then this setup can then be put into a centrifuge for centrifugation. So in order to perform that protocol, we will need the following material. So first of all, classical 1.5 ml Eppendorf tubes and a scalpel blade. Secondly, to make the microcolumn, we will use a 20 microliter gel loaded tip like this one with a very long and thin neck. And in order to pack the C8 plug, we will use a disc of solid C8 phase and two capillaries. So one of them that I will call a big capillary with a fixed internal diameter, and another one that I will call a small capillary with a fixed outer diameter. Then to make the adapter, we will need a 500 microliter Eppendorf tube and a 200 microliter pipette tip. And finally, to pack your titanium dioxide into the column, you will need a titanium dioxide slurry at a concentration of 10 mg per milliliter in 30% acetonitrile, 0.1% TFA. So first of all, we will pack the C8 plug inside of your gel-loaded tip. So in order to do this, you take your two capillaries with the different diameters, and then you will fit the small capillary inside the big one. And so the small capillary will fit inside the big one like this, and you can move it. So this is the reason why I only fix the internal diameter of the big one and the outer diameter of the small one. The other diameters don't really matter. So in order to pack the C8, you will first use the big capillary to extract the C8 phase and put it inside the capillary. So to do that, you need to make sure that the small capillary is well inside the big one. For example, here, it's the end of the small capillary is here. And then you use the big capillary to just extract here some of your C8. Then you make sure that the C8 is actually inside the capillary. And then you use the big capillary, so with the small one still well inside, and you fit it inside your gel loader until you cannot move it anymore. And then you use the small one in order to slowly and gently push out the C8 so out from the big capillary and inside your gel loader. And this is the trickiest part of the whole setup, because you need to make sure that your plug is packed well enough that the titanium dioxide powder will not leak during the protocol. But you also need to make sure that you don't pack it too much, because otherwise your back pressure will be too high and you will never be able to perform the enrichment properly. And then you take your scalpel blade and you will cut the end of the gel loader so that there is still about 3 millimeters of empty tip after the plug, so somewhere here. And then you end up with the microcolumn with the C8 plug packed and a little bit of empty plastic after that. So then we will make the adapter that is used in order to adapt your microcolumn on your Eppendorf tube for the centrifugation. So first of all, you take a 500 microliter Eppendorf tube like this, and you will first cut the lid, and then second you will cut your Eppendorf in the middle, so approximately here, to end up with something like that. And then you take your pipette tip and you adapt it into the now cut Eppendorf, like this. And you will cut the end of the pipette tip approximately here, so that some of the tip sticks out, but not too much. And you will end up with this. So now your adapter is ready, and you can take your microcolumn and fit it in it. And then you can see that the outside of the tip here sticks out of the pipette tip, which is important, because if your microcolumn was inside the tip and you had some liquid around it, then it could go back into the microcolumn just by capillarity. But also, what is important is that when you adapt it into the Eppendorf, like this, you still have quite a lot of empty space here, so that at all the steps, when the liquid is centrifuged out of the column and inside the Eppendorf, the end of the column doesn't drown into the liquid, which could cause some liquid that was ejected from the column to go back in it by capillarity. So then you have your system almost ready, and you just need to add the titanium dioxide slurry in it. So you will first take the slurry itself, and as you can see, the suspension doesn't stay suspended very long. You need to vortex your slurry well in order to make sure that the suspension is homogeneous. And if you pack more than one column, you will need to vortex again every 1 or 2 columns, just to make sure that the concentration of the suspension will remain homogeneous, which will ensure that you will pack your columns in a reproducible manner with always the same amount. So for the amount of titanium dioxide that you will pack into your column, so you need to know that the optimal ratio between the beads and the peptide should be 2 to 1. So 200 microgram of beads for 100 microgram of peptides. So for a classical lysate experiment, you will enrich 250 microgram of lysate, and for that you will need 500 microgram of beads. This 500 microgram of beads is the maximum amount that you can go to for this gel loader method. Higher than that, the back pressure will be too high and your enrichment will not work properly anymore. So if you need to enrich more than 250 microgram of lysates, then you should do several columns and combine the eluates at the end. So that slurry here is at 10 milligram per milliliter, as we said. So in order to have 500 microgram of beads, I will just pipette 50 microliter out of it and add it gently into the column. So then you will just put your setup into a classical centrifuge in order to pack the material by centrifugation. And so the centrifugation will be performed at a very low speed. So here it's 100 Gs. And I put a time of 60 minutes, so that time doesn't really matter. What is important is that for this 50 microliter of beads, the liquid will flow out of the column in 30 to 45 minutes. So what I encourage you to do is to check the centrifugation frequently to make sure that the liquid doesn't go too slow or too fast, in order to have all the liquid out of the column in 30 to 45 minutes. And then when it's done, you can take it back. And you now have your microcolumn packed with titanium dioxide, and you will perform all the other steps of the enrichment protocol in the same way by centrifugation. So the other steps are conditioning the column, loading the sample, washing away the contaminants, and eluting the phosphopeptides. And all of this will be performed by centrifugation with a low speed, and the speed will vary a little bit depending on the step, and we will see this in the following of the lecture. So that's it, your microcolumn is ready, and you can now enrich your phosphopeptides by the protocol. Thank you.